we have here an equation that has a linear part in y prime and y, and then a term that involves a function of t multiplying a power of y. And so those are the Bernoulli type equations. And it's been observed that a good substitution to try in these situations is subtracting the power of y from y to get a new variable. So v is y to the 1 minus 3, and that's y to the minus 2. And now we'll just calculate and see what we get. So v prime is minus 2 times y to the negative 3 times y prime. Y prime is minus 2y minus 4ty cubed. So let's put that in there. Minus 2y minus 4ty cubed. We expand, what do we have? We have minus 2 times minus 2 is plus 4 times y to the negative 2. And then we have 2y to the negative 3 times 4t y to the positive 3. So the y to the negative 3, y to the 3 cancel. And we have minus 2 times minus 4 is 8t. Well, that's wonderful because y to the negative 2 is v. So this is a linear equation in v. And again, that's what this trick is supposed to do. It's going to convert this into a linear equation in v. And so v prime is 4v plus 8t. Now to think of this equation, I move this 4v back to the left, recognize that this is v prime minus 4v is equal to 8t. And to integrate the left-hand side, I need an integrating factor. That integrating factor is going to be something whose derivative is minus 4, e to the minus 4t. And when you differentiate, you get e to the minus 4t v prime minus 4 e to the minus 4t v. That's exactly what we wanted. And the result is e to the negative 4 multiplying v prime minus 4v, and so that's equal to e to the negative 4t multiplying 8t. Now we want to anti-differentiate both sides and solve the equation. We had e to the negative 4tv differentiated, the whole thing, giving us 8t e to the minus 4t. Anti-differentiate the left-hand side. And then on the right-hand side, we need to think of this as a product of 8t and e to the minus 4t and integrate by parts, or think of it as a product. And so when we differentiate e to the minus 4t, we'll get e to the minus 4t again times minus 4. So if we have a minus 2t in front, we'll get 8t. And then when we differentiate the term t here, we get minus 2 e to the negative 4t. We don't want that. And so let's subtract 1/2 e to the minus 4t. When we differentiate this, we'll get plus 2 e to the minus 4t. And so that's good. And then we have a constant of integration. And so v is minus 2t minus 1/2, and then plus c times e to the 4t. And remember that v originally was set to be 1 over y squared. So v should actually be positive. So that's where that should take place. And then y is either plus or minus v to the minus 1/2. And of course, whether this is plus or minus will be determined by whether the y that we're considering has an initial condition that is positive or negative. And then just plugging in the value of v. And again, remember, v has to be positive. So t can only take those values that allow that v is positive. And so that's the domain of the solution.